Okay, so once again, you're welcome back to today's online lesson, and we are still talking about trigonometry. Now, in today's lesson, we are going to look at negative angles. We'll be looking at negative angles when it comes to trig. And then we'll be looking at how to change angles from degrees to radians. These are the two major concepts I'll be adding up today. Then now we'll go through some tutorials because we have exams ahead of us. So we'll be doing some more work examples. All right. Any question before I move on? Please, can you all hear me loud and clear?
Yes, please.
Okay. So now, to begin with, we are looking at what we call negative angles when it comes to trigonometry. We are looking at negative angles. Now, we learned early on that in trigonometry, angles are measured from the positive x-axis in the anti-clockwise direction. So if I have the Cartesian plane drawn and I have my x-axis here, my y-axis there, for positive angles in trigonometry, they are measured from the positive x-axis in the anti-clockwise direction. That gives us positive angles. We've said much about them, so I'm not going to go into that again. But when it comes to negative angles, then you measure them from the positive x-axis in the clockwise direction, and that gives you negative angles in trigonometry. The reason why we are looking at how to manipulate negative angles is for the fact that there's another subtopic we'll be considering, which is equations involving trig. And sometimes you may get your angles in negative, but you need to get the answer in a positive angle form. That is why there's a need for you to know how to work with negative angles. That's why we are considering that today. So we learned early on that within the Cartesian plane, all the trig ratios behave differently. And I know you are going to tell me the behavior. It's just a little revision before I move on deeply into the negative angles. So we found out that we have the first quadrant, we have the second quadrant, the third quadrant, then the fourth quadrant. In the first quadrant, what is the behavior of the trig ratios? For sine, cos, and tan, what's the behavior?
They are positive.
So all the trig ratios are
All
positive.
positive.
They are all positive in the first quadrant. When it comes to the second quadrant, we have only sine that is positive. When it comes to the third quadrant, we have only tan that is positive. The rest are negative. And when it comes to the fourth quadrant, we have only cos that is what? Positive, or cosine. So in as much as we are looking at negative angles for which we read it from the positive x-axis in the clockwise direction, meaning that when you start reading the angle in the clockwise direction, it will start from the fourth quadrant. So in this case, if I have cos of negative 40 degrees, ideally we should be able to know what its value is. Now let me use the special angles actually, so that we'll understand it better using the special angles that we've learned early on. If we have cos of negative 30 degrees, we should know its value of head. But what does negative 30 degrees refer? If I should represent this on the Cartesian plane, then it means that I'm going to have my 30 degrees read from the positive x-axis in the clockwise direction. Then I draw my terminal line. So what it means is that we have our negative 30 degrees represented within the fourth quadrant. So ideally, cos of negative 30 degrees, since the 30 degrees finds itself in the fourth quadrant, what is the behavior of cos in the fourth quadrant?
Cos is
It's
positive.
cos is positive. So it means that even though we are finding cos of negative 30 degrees, as long as that negative 30 degrees finds itself in the fourth quadrant, then it means that it's still going to be cos of 30 degrees, because automatically cos in the fourth quadrant is positive. So it doesn't matter if I'm measuring an angle which is negative and it finds itself in the fourth quadrant. As long as cos in the fourth quadrant is positive, then it means when you find cos of any negative angle, it automatically becomes a positive angle. So we have it as cos negative 30 degrees is the same as cos 30 degrees. Likewise, cos negative 50 degrees is still going to be cos 50 degrees. Likewise, cos negative 60 degrees is still going to be cos 60 degrees. The reason being that the negative 60 degrees finds itself in the fourth quadrant, and in the fourth quadrant, cos is positive. So it doesn't matter whether the angle is negative, still it's going to be positive. Are you with me, please? Are you with me?
Sir, please can you repeat what you said?
I was saying that we are looking at negative angles, and negative angles are read from the positive x-axis in the clockwise direction. So we are starting with cos of negative 30, and cos of negative 30, we said that negative 30, which is the angle, when we sketch it, it finds itself in the fourth quadrant. But what is the behavior of cos in the fourth quadrant? And we found out that the behavior of cos in the fourth quadrant is positive. So it means that cos of negative 30 degrees, even though it is a negative angle, it is going to be a positive angle for cos, because in the natural sense, cos is positive in the fourth quadrant. So generally, when you find cos of any negative angle, and that negative angle finds itself in the fourth quadrant, automatically becomes a positive angle. And that is why I wrote cos of negative 50 degrees is the same as cos 50. Cos of negative 60 degrees is the same as cos 60. So it means that if you have any angle lying within the range of the fourth quadrant, so if you have cos of negative theta, it becomes cos theta, positive angle. Please, are you okay?
Yes, please.
Now, kindly take your calculator. Perhaps you may think that I'm just telling you something to convince you. No, your calculator can even confirm it for you. By the way, cos 30 is what answer? What value is cos 30? We did it the last time.
It's root 3 on 2.
Root 3 on 2. So it means with your calculator, I believe you have your calculator available.
Yes, please.
So take your calculator and program on your calculator cos open bracket. I hope you have it. Then negative 30 degrees. Then you close the bracket. When you press the equal to sign, it will give you root 3 on 2, which is a positive angle or a positive value, sorry.
Yes.
Likewise, program cos, just edit it and make it negative 60. You realize that it will give you the answer as half.
Yes.
So cos of negative angle automatically becomes what? Cos of that positive angle. Please, are we all okay?
Yes, please.
Now let's verify the other trig ratios in the fourth quadrant in terms of sine. So if we have sine of negative 30 degrees, sine of negative 30 degrees, the negative 30 degrees is an angle which lies in the fourth quadrant when you sketch it. But what is the behavior of sine in the fourth quadrant?
It's negative.
It's negative. So it means that sine of negative 30 degrees is going to be the same answer as negative sine 30 degrees. So when you simplify, it gives you negative half. Again, we are talking about negative angles, and negative angles are read from the positive x-axis in the clockwise direction. So if you have any angle lying within the fourth quadrant to begin with, if you find cos of it, it becomes a positive angle altogether. If you find sine of it, it becomes a negative angle to it altogether. So in this case, having sine of negative 30 degrees is the same answer as negative sine 30. And I believe you can program on your calculator to confirm it. Program on your
Yes,
calculator.
please.
So please, I hope you are all with me.
Yes.
Then what do you think tan of negative 30 degrees will be? It will be the same as, yes,
It's negative tan of 30 degrees.
negative tan of 30 degrees. And we learned that tan 30 was what value?
Tan 30 was root 3 on 3.
So it means negative tan of negative 30 degrees is the same as negative root 3 on 3. And you can confirm it from your calculator.
Yes.
Please don't forget these ideas. We'll be using it when it comes to trigonometric identities. So don't forget them. Don't forget them at all. We'll be using them a lot. That's why I'm taking my time to explain the concept for you to get it right. Okay, so let's move forward. Moving forward, I'm increasing the angle. This time around, I have cos of negative 120 degrees. Now, ideally, when you sketch cos of negative 120 degrees, which quadrant will it find itself, please? Yes, negative 120. It means it will bypass
I know. You have
the
to use your
90
center.
degrees
Right.
and then it will move into the third quadrant. I hope you all agree with me.
Yes, please. It's okay. I'm making
So
it.
this is
Use
what we
center.
have here. This angle here represents the negative 120 degrees. So it means that angle finds itself in the third quadrant. It finds itself in the third quadrant. But in the third quadrant, if I may ask, what is the nature of cos?
Cos is negative x on y.
Pardon?
So it's negative.
It's negative.
Cos is negative.
So cos is negative in the third quadrant. So it means cos negative 120 degrees is going to be the same as negative cos of 120 degrees. But then the question again is, what special angle can we get from 120 degrees? Yes, what special angle can we get from 120 degrees? The last time we spoke about it, that all the angles have their special angles within it. Yes, so 120 degrees. What special angle can we get from 120 degrees?
Can you say 60 degrees?
Yes, we can say it is 60 degrees. It is 60 degrees. So it means that this is the same as negative cos 60 degrees. It's the same as negative cos 60 degrees, which is going to be negative half. So when you program on your calculator, you can check it from your calculator. Cos negative 120 degrees, the answer is negative half. Why is it negative half? Negative half for the fact that the 120 degrees itself finds itself in the third quadrant. And in the third quadrant, the behavior of cos is negative. And the special angle we can get from 120 degrees is 60. And cos 60 is half. So it means you are going to end up getting negative half. Please, can you confirm it on your calculator?
Yes, please. It's negative half.
Are you all following me?
Yes, sir.
The next one, sine of negative 120 degrees. Yes, I'm listening.
First, and cos is also negative in the third quadrant. So won't it become positive instead?
Can you take it again? Your line was breaking, so I wasn't getting the question.
Sorry, sir. Can you hear me now?
Yes. Just take it one after the other.
Please. I said the figure was negative 120 and cos is also negative in the third quadrant.
Yes.
So wouldn't it be positive at the end of the day?
No. What I'm saying is that cos of negative 120 degrees is the same as negative cos 120. In other words, we are just taking the special angle that is found in 120, and that is 60 degrees. So the 120 is no more going to be there. So cos of negative 120 degrees is being represented as negative cos 60, and that is negative half. Please, is it clear?
Sir, please. I don't really understand why the negative is not cancelling.
The negative is not going to cancel because in the first place, we've brought the negative out. We've just taken it out. We've understood that per the graphical operation, if I have, I'm not finding just cos of 120. I'm finding cos of negative 120. And cos of negative 120 is going to be negative of cos of 120. And therefore, the special angle found in 120 is 60. And that is why it's supposed to be negative cos 60. If not, then you can go straight ahead. If maybe this might confuse you, then you can go straight ahead and say that, because I was trying to explain that cos of negative 120 degrees must be equal to negative cos of that angle. And cos of that, negative cos of that angle, what is that angle there? We have 120 degrees there. So it means we are trying to take it out from the graphical perspective. And then now we introduce our 60 degrees and then you get a final answer as that. I don't know if I'm making it clearer for you. The question wasn't, now get me right, the question wasn't find cos of 120 degrees. The question wasn't find cos of 120 degrees. If the question was find cos of 120 degrees, then that would have been that's where the cancellation would have taken place. But we
Sir,
have, yes,
please, I think I have a contribution to make, and maybe
okay,
it will clear my doubts.
okay,
He said cos in the third quadrant is always negative. So it doesn't make the figure they've given us negative. For the negative signs to be true, for them to cancel, right? It's only
yes,
giving us an idea that the final answer has to be negative.
yes. That's what I want to explain. It's just giving us an
Okay, so it's
idea.
clear now.
Okay, okay. So we are just,
Thank you.
oh, you're welcome. So we are just saying that cos of the angle which is negative, since the angle negative 120 degrees, when you read it, it's supposed to find itself in the third quadrant. Then it means that we must obtain a negative solution altogether. And that is why I just wrote this one again. If that is clear, then we can move
Sir,
forward.
please, if I may ask,
Yes.
please, what's the subtopic?
The subtopic is finding the trig ratios of negative angles.
Okay.
I guess you just joined us, right?
Yes, please.
Okay, because I made mention of what we are treating today. We are looking at finding the trig ratios of negative angles, and then also we are looking at the second aspect, which is changing angles from degrees to radians, and then vice versa. These are the two main things. Then after that, we'll be taking some work examples. We'll be having some tutorials based on what we've done so far because of the exams
Okay,
at
sir.
stake. All right.
And so will you be giving slides on it or something like that?
Pardon?
So please will be giving slides on it or like questions on like nice for the exams.
Can you take it again? I didn't hear you clearly.
So please can you hear me?
Yes.
So please I was asking if like in the course of revision will you give us slides or questions to try out just to prepare us for the
Yes.
exam?
Generally, I'll just tell you what you should be expecting. You know, you've done a lot of topics way back in school, and we've added some. So it means we are going to mix them up. It's not going to be only what we've done today or what we've done whilst we were home.
Oh, okay.
All right. Okay, so ideally, again, coming to sine of negative 120 degrees, because the negative 120 degrees is a negative angle, when you sketch it, we've already had a sketch of negative 120 degrees. It finds itself in the third quadrant. So since it finds itself in the third quadrant, then it means we are expecting a negative angle altogether. We are expecting a negative angle altogether. Then now again, you ask yourself, what special angle can we get from 120 degrees? Yes, what special angle? And that is what we've verified.
60 degrees.
That is 60 degrees. So it means negative sine 120 degrees is supposed to be negative sine of 60 degrees, because that's the special angle that we can obtain from 120 degrees. And that is the final answer of, yes, sine 60 is what?
√3 on 2.
So we have it as negative √3 on 2. And you can verify from your calculator. When you program sine of negative 120 degrees, the final answer is negative √3 on 2. Are we all okay?
Yes, please.
All right. Now, so it means we've moved into the third quadrant. Let us take the last one. Tan of negative 120 degrees. This is what we are working on. Then again, you ask yourself, this negative 120 degrees, which quadrant will it find itself in? And the
The
answer
third
is
quadrant.
the third quadrant. What is the behavior of tan in the third quadrant?
Tan is positive.
Tan
It's
is,
positive.
so it means it doesn't matter because we are having negative angle. As long as the behavior of tan in the third quadrant is positive, then it means we are expecting a positive solution. And therefore, then we ask ourselves, what special angle do we have in 120 degrees? And that is 60. So tan of negative 120 degrees, the answer is positive tan of 60 degrees. And you can use your calculator to verify.
Yes.
Please, I hope each and everyone is following what I'm doing carefully. Because as I
Yes,
said,
please.
these ideas are needed for the fact that when we launch into the deep and then we start looking at equations involving trigonometry, sometimes the angles or the answers you'll be getting might be negative angles, others may be positive angles, and you should be able to know how to manipulate and get your right answers. That's why you must know this. Okay, so now let us move on to the next. And the next, I'm looking at getting, let's say, cos of negative 240 degrees. Then we have sine of negative 240 degrees. Then we have tan of negative 240 degrees. Now, negative 240 degrees, when you make a sketch of it, which quadrant will it find itself?
Sir,
Yes, where?
please, tan of negative 120, I had √3. Shouldn't we break the tan 60 degrees
Oh,
down?
okay. Oh, sorry. So you are giving me the final answer as that. I thought we are done with it. So the final answer is √3.
Yes.
Yeah. Thank you for that. Because I wanted us to move on faster. Either and that we wouldn't be able to finish and then have the tutorials.
Okay.
All right. So this time around, we are looking at negative 240 degrees. So negative 240 degrees, I asked the question, which quadrant will negative 240 degrees find itself?
In the second quadrant.
In the second quadrant. So it means that we have uh, 240 in the second quadrant and the terminal line will be here. The terminal line will be here. So this angle will go around and come and meet this. And that is a negative 240 degrees. Then the question now is, what special angle can we get from 240 degrees? Yes, what special angle can we get from there? What special angle do we have in 240 degrees?
30
Sir, 30
degrees.
degrees.
That is 30 degrees. Very good. That is 30 degrees. So now, since we are finding ourselves in the second quadrant, then the question is, what is the nature of cos in the second quadrant?
Sir, please, it's
Sir, it's
negative.
negative.
It's negative. So in other words, cos of 240 should be negative. Are you sure that it's 30 degrees? Is it 30 or 60? Check it for me.
Sir, do we do um
Because that's
180 is
the
it 240 minus 180?
it's 240 minus 180 because that angle must be subtended on the x-axis.
Yes, it's 60
So it's
degrees.
60 degrees, yeah. So correct it. So cos of negative 240 degrees is the same as negative cos of 60 degrees. And that will give you the negative half. Now, sine of negative 240. Negative 240 degrees has seen itself in the second quadrant. In the second quadrant, what's the behavior of
Yes.
sine? What's the behavior of sine?
Sir, it's negative.
What's the behavior of sine in the second quadrant?
Please, it's
Sir,
negative.
please, it's positive.
It's positive. Sine is positive in the second quadrant. So in other words, sine of negative 240 is the same as sine of 60 degrees, which is root 3 on 2. And then finally, tan of negative 240 degrees. What is the behavior of tan in the second quadrant?
Sir, it's negative.
It's negative. So we are supposed to obtain negative tan of 60 degrees.
This tan is negative.
Yes, tan is negative. And that will give us negative root 3. So please take note of this. Whenever you are given any negative angle to deal with, you ask yourself, when you sketch that angle, which quadrant will it find itself? That's one. Then number two is, what is the behavior of the trig ratio of that angle within that quadrant? And that is when your solutions will be generated. Please, are we all okay?
Sir, please, I want to be clear on something.
All right, I'm listening.
Sir, please, when you want to find a special angle, it must always be drawn to the x-axis, right?
Always to the x-axis.
To the x, okay.
Always to the x-axis. So perhaps to clear any form of doubt, watch carefully. I have an angle here in the first quadrant. Please watch carefully and follow carefully. Me, I don't like cheap or pass. I want understanding. So when I score well. That's why I always say that you need to learn with understanding. Now, I have an angle here, theta. That theta has been drawn towards the x-axis. So there's nothing that you need to do or subtract. So you maintain it as it is. But if it should happen that I have an angle drawn in the second quadrant here, and then, are you listening? Someone is fidgeting. Please stop and then listen. and then you have your theta drawn. You have your theta drawn from here to that. That angle is so huge. Therefore, how do I get the special angle? The special angle must be drawn towards the x-axis. So how do we get that angle? This is the angle we are looking for, but they've given you theta, which is here. So if theta is that green big space, and I want to find the white space, and that will be the special angle we are interested in, how do I get that white space? What must I do to the theta?
You subtract
You subtract it from what?
from um 180.
From 180 degrees. Then it will give you the special
Please,
angle.
I think you subtract from one. Yeah.
You subtract it from 180, then it gives you the special angle. Then again, if we come to another quadrant, let me draw another. I come to another quadrant, and then this time around, the angle was shown in the third quadrant. And you know, theta is so big. How do I get the special angle? It means I have to come back. This is where the white space is the special angle, because it must always go towards the x-axis. So how do I get the special angle? What must I do?
Sir, I'm trying.
All right.
Do you subtract 180 from it?
So it will be 180 out of the theta. So it will be theta
From the theta.
minus 180.
Okay.
Theta minus 180. Then you get the special angle. And that is all. That is all.
Okay,
Where,
so sir,
whereas over here, it was 180 minus theta. When it comes to the third quadrant, to get the special angle, it will be theta minus 180. I'm listening, please.
so I just wanted to say that. So does it mean that when you're now finding it in x-axis, you use you subtract the theta from the degree of that quadrant, but
Yes.
when it's already at the one sorry, when it's already drawn to the x-axis, you subtract it from the theta rather.
Yes.
Okay, sir.
Good. So we are done with negative angles, and we've seen the behavior of all the trig ratios for negative angles. We are moving on to the next. And moving forward, in trigonometry, there are two forms of angles we deal with. We have what we call the degree. We measure in degrees, and then we measure in radians. So in trigonometry, angles are measured in degrees and radians. There are more, but at your level, these are the two main forms you must know: degrees and radians. I believe that way back in JHS, you knew that angles are only measured in degrees through the help of your protractor, right?
Yes, sir.
But since you are getting matured, then you should also know something about radians. So in trigonometry, angles are not only measured in degrees, we can equally measure them in radians. Now, how come the word radians came on board? It's coming from the word radius. But because it's an angle, that's why it is known as radians. Now, this is how the whole concept is. It's so easy. You definitely understand it. Trust me on that. It's so easy. It's just a formula base. But let me explain how you can get it right. Now, where do we have radius? Where can we find radius? Please tell me. Radius can be found in where?
A circle.
Thank you. So in a circle. In a circle. So this is my compass. And therefore, if this is my compass, sorry. Hold on. Let me get this thing. Alright, so if this is my compass, I can draw a circle. So if I have a circle, what is the total angle made in a circle?
360 degrees.
360 degrees. We have 360 degrees measured in this given circle. Now we are moving forward. We are moving forward. And in a circle, we have radius. We have radius. Let me introduce another radius here. All right, so this gives me something like a sector. Beautiful. Now, so we have an angle theta found in it. This is our radius, as I said. So ideally, 360 degrees is equivalent to, yes, you have this idea in mind, whereby radius is found in there. Generally, we have the circumference of the circle known, right? Circumference. Yes. How do you find the circumference of a circle? The total circumference of the circle. How do we generate it? That's where you can get radius in it. Yes, circumference of a circle is given as what?
So, I don't know, 2 pi r.
2 pi r. I've told you, don't chew and pour. Understand and remember easily.
Okay.
So circumference of a circle is given as 2 pi r. So do you see the radius there?
Yes, sir.
Good. So ideally 360 degrees is equivalent to 2 pi radians. Is equivalent to 2 pi radians. So in other words, if I want only 1 degree, what should I do to the left hand side of this equation? I divide here by 360 degrees, divide here by 360 degrees. So the degree thing will be left out, giving me 1. When you break this down, what are we getting? So 1 degree is equivalent to, what are we getting here? 2 can go into 360 how many times?
180.
So we are going to get pi on 180 radians. So 1 degree is equivalent to pi over 180 radian. Then again, so with this same formula, with this conversion, 360 degrees is equivalent to the circumference of a circle. So 360 degrees is equal to 2 pi r. Hence, 1 degree. If I want 1 degree, how many radians am I going to get? 1 degree will be equivalent to pi over 180 radians. Then again, from the same relation, 360 degrees is equivalent to 2 pi radians. Now, if I want 1 radian, what must I do on the, it means the 2 pi must move away, right? because I want the r to be left.
Yes,
So
sir.
what must I do on the right hand side? Divide here by
So you
what?
divide by 2 pi.
2 pi. Divide here also by what? 2 pi.
2 pi.
So it means 2 pi cancels out. To be left with 1 rad. So 1 rad is equivalent to, when you break this down, what are you going to be left with?
So 180 over theta. Hey, 180 over
180
pi.
over pi. 180 over pi. So in conclusion, 1 rad is equal to 180 over pi. And then 1 degree is what? The opposite. The opposite is what?
So
The opposite. The reverse of this is
Pi
what?
over
Pi
pi over
over
180.
180. So this relation here is very important for you to be able to change angles from radians to degree, and then from degree to radians. Please, am I clear?
Sir,
yes,
Yes,
sir.
please. If you can't remember this, remember where it's coming
please,
from.
can you
Your line
show
is breaking, so we can't.
the slide before this one again? So the one before this one. I want to check the slide before.
Yes,
Yes, please.
I've gone back.
Sir,
So
please,
I'm
you can move on now. I've done it.
okay. So as I said, if you can't remember this, the best way you can easily remember is to use 360 degrees is equivalent to 2 pi r. Then from here you can generate your formulas and work it out. So you may have 30 degrees. You should know 30 degrees in radians. You may have 60 degrees. You should know 60 degrees in radians. You may have 90 degrees. You should know 90 degrees in radians. You may have 45 degrees. You should know 45 degrees in radians. Likewise, you may have 360 degrees. You should know it in radians. And then 180 degrees, you should know it in radians. So the question now is, if I'm given 30 degrees and I'm asked to find the answer in radians. But let me give you a clue here. Whenever they want the answer in radians, automatically pi is going to be introduced in the question or the solution. You always see pi on board. So that's when you have 18 radians. So this is how you go about it. We want the answer in radians. 1 degree is equivalent to pi over 180. How about 30 degrees? This proportion. So it's going to be 30 times pi over 180. And the final answer is 30 can go into itself 1 and go into 186. So the final answer is pi over 6. So 30 degrees is the same as pi over 6. Are you with me?
Sir,
Yes.
Yes, please.
please can't you just break pi down because there's pi on the calculator?
No, I beg of you, never use the pi on the calculator. I know where it is. The pi on the calculator is found at times 10 exponent x, right?
Yes, please.
Good.
Yes.
The programming on the calculator for pi is wrong. So please never use the pi on the calculator. I beg of you.
Sir, only for this subject.
For every subject, any
Several
mathematical
subjects.
subjects, If they
Okay.
ask you to substitute pi, it is better to substitute it as 22/7. Now, perhaps you may think I'm telling lies, so let's verify it together. You see what I'm talking about. Just program 22 on 7 on your calculator. 22 divided by 7. What answer are you getting in decimals?
3.14.
So 3.142857143. Now it goes on and on and on, but because your calculator can only display 10 digits, that's why it's limited. When you use a laptop to do that, it will give you more. Now your calculator, pi, on the calculator, just press shift and that pi and press equal to and send it to SD. Add
3.141592654.
so 3.141592654. Is this value the same as what is here?
No.
So I beg of you, never use the pi on the calculator.
Okay, sir.
So going back, 60 degrees to radians.
So,
Yes, please.
please, why is it that you leave it as pi over 6? Why don't you just like put in the figures at once and
No. Whenever they want the answer, this is a scientific notation. When they want the answer in radians, then they want it as this. You
so
don't
you
have to
don't put
give
it in
in
figures?
decimals. No. Unless they want it that way. And then they will tell you, take pi to be.
Okay.
Yes. If not, please leave your answer always in pi whenever you are dealing with radians.
Yes, sir.
Yeah. Please, are we all clear? In the same way, perhaps it was, watch, in the same way, they gave us pi over 6, even though we know the answer is 30 degrees. And they said that give the answer in degrees. Then it means that what we must do is, we know that 1 rad is equivalent to what? It's equivalent to what? 180 over pi, right? Are we all here?
Yes, sir.
So how about pi over 6? That will be equal to pi over 6 times 180 over pi. So at this point, the pi's will cancel out. Then 6 will go into 180, 30. So the final answer becomes 30 degrees. And that is how you change it from radians to degree. That is how you change it from radians to degree. So when you are changing it from radians to degree, just multiply your radians by 180 over pi. And because the pi's has to cancel, that's why you have to multiply by 180 over pi, so that it will be left with the angle in degrees. If you are changing it from degree to radians, then because pi needs to be maintained, it will be pi over 180 multiplying the angle in degree, and then the pi will still be maintained, and then you get your answer. Please, are we all clear? Are we all clear?
Yes, sir.
All right. Okay, so far so good. We've been able to go through our objectives, dealing with the trig ratios for negative angles, and then also converting angles from degrees to radians and from radians to degree. Our last aspect is tutorial. So some work examples. We've done a lot under trig, because in my next meeting with you, we are going to look at trig identities. But what we've done, trust me, goes a very long way. And I can set about 100,000 questions on what we've done alone. Now, let's begin with this question. Let's begin with this question. Now, it goes as this. In the diagram, ABC is a right angle. So I have a diagram as this. I really love this question. And trust me, it's a WASI question altogether. So in the diagram, so B is here, C is here, and A is there. And we have Y centimeters here. And then we have X plus 2 centimeters. And then we have 45 degrees as an angle here. Please, have you all gotten the diagram?
Yes, sir.
Okay, so the question, I'm writing the question. In the diagram, ABC is a right angled triangle. In which the line AB is equal to Y centimeters. The line AC is equal to X plus 2 centimeters. And angle ACB is equal to 45 degrees. Now there's a question. Find Y in terms of X. Find Y in terms of X. What comes into mind? This is the diagram we have on board. How do we find Y in terms of X? In other words, what does it mean? Yes, any idea? Find Y in terms of X. I believe this is not the first time you've heard of
Find what? Find what?
find Y in terms of X. What does this language mean?
Why you
We should
find
find Y
why using
using X. Okay, all right. Or in other words, it means make Y the subject in terms of X. So you need only Y equal to something with respect to X. So how can we find Y in terms of X per the diagram here? And based on the information given, what must you have in mind? You have to generate an equation, obviously. How can we generate an equation based on the information given to us from the right angle triangle? Yes, how can you?
sir.
Yes.
So you can use your trig ratios.
Which trig ratio are you going to apply based on what we have here?
So please the so.
You use the so. What is the so? I don't understand the so.
So please, the sign,
So
the
we use the
SOH.
sign. Okay, so we use sign. So sign is the appropriate statement we can connect with the information we have here. Because from the right angle triangle, we automatically know the hypotenuse, which is x plus 2. We know the opposite side represented as y, and then the acute angle is there. So since we are told we can use sine, then it means sine of 45 degrees must be equal to the opposite side, which is y, over the hypotenuse, which is x plus 2. And remember, we are to make y the subject. So sine of 45 degrees, what have we learned sine 45 to be? Sine 45 is what?
The root 2 on 2.
Root 2 on 2, thank you, is equal to y over x plus 2. So making y the subject, what must we do?
So multiply both sides by, okay, multiply both sides by x plus 2. Then cancel out.
Exactly. So we are going to have it as root 2 on 2 being multiplied by x plus 2 is equal to y. So final answer is what is here. Root 2 on 2 x plus 2. Are you with me?
Yes, sir.
So this is one example. Oh. You see indirectly how we set questions. Have you seen how we set questions? This is where you say that the teachers are wicked. We'll give cheap questions as work examples, but when we give exams, then we give something that you need to think. That's why I
That's so
told you
you know.
that. No, not that I know, but the issue is that students always want cheap side. We bait you to understand the concept, but they always want to just chew and pour instead
So, but
of
you have
they
to start giving the hard ones as trials.
listen. When you give the hard ones as trials, the student will not
It
have the
prepares you.
interest. No, the student will not have interest in learning. But when you bait the person to understand, then now you have tutorials and bring in the tough ones, then it means yes, you are mixing everything all together. So my dear student, you remember I told you that you should understand the position of each of the angle and everything. If you don't have that understanding, trust me, it will never come into your mind as to know what to do. If I have not talked about sine of special angles, you wouldn't have known that sine 45 is root 2 on 2 automatically. And if you don't understand the language, find y in terms of x. It means you'll be sitting down looking into the skies and there's not going to be any help coming because you don't have the understanding. So my dear student, please let's understand whatever we learn. Don't let us make it chewing, pouring, and that's all. No, it wouldn't help any of us. Please, are we all clear?
So, but please, understanding comes from solving more questions, right?
It's part of it. It is not just solving more questions. Oh, then it means you are just learning by solving questions. No, you need to understand the concept before you can even attempt solving questions.
No, okay, sir.
All right. My next question, very interesting question again. Very interesting question.
Interesting means scary.
No, it's not scary. This one is so lovely. Now, this is how the question was given. It says that, yeah, let's see how we can go about this question. Given that, let me go to another page. Given that, this is the elective math aspect of that kind of question. Given that sine x is equal to 5 on 8 where x lies between 0 degrees less or equal to x and less or equal to 90 degrees. Find correct to 3 decimal places. Cos x minus sin x all on 2 tan x. All right. Any idea as to how to solve this question?
Sir, please. Let me
Yes.
tell you what would come into mind if I saw this question.
All right. I'm listening.
I would just find the sine inverse of 5/8.
Yes.
Yes, to find the x.
So it meaning
Then
you
I
are
can now come and put it inside the equation.
okay.
That's
Okay.
what I would have done.
That's a brilliant idea. But I always advise students not to be using that idea all the time. Because when you do so, it means you are going to have some premature approximations, and that can cause your solution. We might not have enough time, either that we would have done it online for everyone to see what is going on. Try finding the s value by finding the sine inverse, and then after which you come and find you substitute it in there, and then it will be leading you to so many decimals which you may be tempted to approximate, and the final answer may be slightly different from what the actual answer needs to be obtained.
Okay, sir.
All right. So the strategy we always want students to adapt when it comes to such questions is that you should be able to use only this information, which is sine of x 5 on 8, to generate cos x and also to generate tan x. Now this sine of x, which is equal to 5 on 8, where did it come from? Where did they obtain it from? Yes, the trig ratios came from where? Where did it come from?
Sir, asking.
Where the trig ratios generated from? Where was it
A
deduced from?
triangle.
Right-angled triangle. It came from a right-angled triangle. So it means that the way forward in solving this question is you must have a right-angled triangle for which from this right-angled triangle the x was somewhere. And what is the definition for sine of x? Yes, 5/8. The 5 is representing the what?
So the opposite.
So the opposite side of x is 5. The 8 is representing what?
The hypotenuse.
Hypotenuse. So from this right angle triangle, the hypotenuse is 8. So because cos needs adjacent, then I need to find the adjacent side. Tan also needs adjacent. So how can I get the adjacent side? Let me call it A. So how do I find A based on the information here?
So you can use the Pythagorean.
We'll use the Pythagoras theorem, and therefore we are going to get it as 8 squared, which is the hypotenuse squared, equal to 5 squared plus A squared. Massaging it, you get A is equal to square root of 8 squared minus 5 squared. Going further to massage, you have it as square root of 64 minus 25, which is what answer?
Sir, square root of 39.
Pardon?
Square root of 39.
Square root of 39. So you realize that square root of 39, if you are tempted to use a calculator, you get it in decimals. So you maintain it as it is as square root of 39. Are you with me?
Yes, sir.
Good. So now Then you come and find what cos x is. Cos x actually is the adjacent side. What is the adjacent side? Square root of 39 on the hypotenuse. The hypotenuse is what? 8. Then you find tan x. Tan x will be what? Yes, help me with that value. Opposite
5 over root 39.
which is the same as 5 root 39 over 39. Do you agree?
Or did you rationalize it?
Yes, we rationalize. So ideally, I've seen what my cos of x is. I've seen what my tan of x is. And I know what my sine of x is. But in all these cases, please listen to me carefully here. Remember, they gave us an interval. What was the interval? Which quadrant does it mean this is found?
So the first one.
Very important. You should be careful with it. You should be careful with it. So it means in the first quadrant. And in the first quadrant, what is the behavior of all the trig ratios? They are
All positive.
They are all positive. So it means all the values that we've obtained here, they are right. So we are supposed to use them as they are, the ratios that we have here. If the range was different, let's say from 90 to 180, then it means you are talking about second quadrant. So second quadrant, you should know that it is only sine that is positive, but the rest are negative. So it means after going through these co-meanings that I've done here, if it was from 90 degrees less or equal to x and less or equal to 180, then it means the cos x that I've found, I would have negated it. The tan x that I've found, I would have negated it. Are you following what I'm saying?
So like it won't come automatically. You have to negate it yourself.
You have to negate it yourself because from the question, they've given you a range whereby the angle lies. And you should know that the trig ratios behave differently within respective quadrants.
Okay, sir.
So at this point, since we are working in the first quadrant, then it means whatever we've had here is right. We keep on maintaining it. So you just simply substitute and program because it's a section A question. Then you program everything all together. Even if it's section B, this is a procedure you have to go through. So cos x was seen to be root 39 on 8 minus sine x, which is already given in the question as 5 over 8, all divided by 2 multiplying tan x, which is 5 root 39 on 8. So if you are able to get all this thing right, have you seen that? It means you've not given any premature approximations. It's only your final answer that you are going to approximate. Are you following me? Because when you punch everything on the calculator from this perspective, then it means it is only your final answer that you are going to approximate. Please, are you with me?
Yes, sir.
So these are some of the other questions under trig 1. These are the other questions under trig 1. Please, can you give me the final answer, please? Let me give you the possible answers. So I have A as where are you? 0.089, 0.089, B as 0.097, C as 0.019, then D as 0.020. Please, what was the When you program all this on the calculator at the go, what's the answer? Let me write all before we choose the right answer. Then I'll give you my last question. Yes, who is helping us with the solution?
Sir,
Yes.
sir, please, I got 0 point. Sir, I'm coming. 3 decimal.
No, you just give me all the value. Don't give me the 3 decimals.
Oh, okay. 0.01993.
199.
3.
So in other words, when you approximate it, it becomes 0.012. 0.020, sorry. And that is possible answer D.
Yes, please.
Possible answer D. Okay, my last question, because our time is up. Our time is up. My last question says, convert 225 degrees to radians. Convert 225 degrees to radians. Yes, do it for me and tell me the answer. Yes, what's the answer, please?
Okay, it has come.
Yes, what's the answer? No one is sharing her answer with us.
Sir, please, I just saw the question. I'm coming.
Sir,
Yeah,
please, I'm not sure. 5 pi over 4.
so you had 5 pi on 4. Yes, any other answer? Any other answer apart from 5 pi on 4?
Sir, please, the same thing.
You are perfectly right. You are perfectly right. So all that you needed to do to
Sir,
get your,
please, I got the same thing.
yeah, it's right. So it's supposed to be 225 times pi over 180. Then now you break it down and you get the answer as what is here. Okay, how about this one? 5 pi on 6. Convert 5 pi on 6 to degrees. Yes, convert it to degrees. 5 pi on 6 rad to degrees. Yes, what answer are you getting?
So I'm getting 150 degrees from
Pardon?
Sir, please, it's not 150
so
degrees.
I can hear me.
Is it 150? Were you all getting 150 degrees?
Yes.
You are also right. So all that you needed to do to get the answer is 5 pi on 6 needs to be multiplied to 180 over pi. So pi will cancel pi. 6 will go into 180. How many times? 30 times. 30 times 5 is 150 degrees. So that's it. You are right. Thanks so much
So
for.
please, are these solely objective questions?
Yeah, it's solely objectives. It's going to be objectives. Just purely objectives.
Okay, sir.
Yeah, maybe another time we'll look at subjective. But for now, trust me, I don't joke with my objectives at all because objectives can pass you so well and faster than subjective. So be practicing your objectives a lot. Be practicing your objectives a lot. And that tells you how fast you are. Unlike subjective, that one with mark steps, objective, if you get it wrong, Charlie, you are done.
Okay, sir.
All right. Thanks so much for joining the call. It's a great privilege having you on the line. Have a lovely evening. Bye bye.
Bye, sir. You too.